For decades, astronomers believed they had the universe mostly figured out. Not completely solved, but understood well enough. There was a timeline. A structure. A story that made sense. It began with the Big Bang, a single moment roughly 13.8 billion years ago when space, time, and energy came into existence. From there, everything followed a predictable path. The universe expanded. It cooled. Matter began to clump together. Tiny fluctuations in density slowly grew under gravity, forming the first stars, then galaxies, then clusters, and eventually the vast cosmic web we see today. It was elegant, orderly, comforting. And then, the James Webb Space Telescope started sending back data. At first, everything seemed normal. Sharper images. Deeper views. More detail than ever before. Exactly what scientists expected. But then something changed. The deeper Webb looked, the less the universe behaved the way it was supposed to. Milky Way, a universe that grew up too fast. 7 According to standard cosmology, the early universe should have been messy. Chaotic. Immature. The first few 100 million years after the Big Bang are often called the cosmic dawn, a time when the universe was just beginning to form structure. Galaxies during this era should have been small or regular, chemically simple, basically cosmic infants. But Webb is seeing something very different. It's finding galaxies that look too complete, too organized, too massive, too evolved. Some of these galaxies appear to have already formed billions of stars. Others show surprisingly complex structures, disks, bulges, even early signs of rotation. And perhaps most puzzling of all, their chemical fingerprints don't match their age. Test tube. The chemistry. Problem 6 in astronomy, chemistry tells a story. The first stars in the universe were made almost entirely of hydrogen and helium. Heavier elements, like carbon, oxygen, iron, only form later, inside stars, through a process known as stellar nucleosynthesis. And those elements don't just appear instantly. They require stars to form, stars to live, stars to die, often violently, new stars to form again from enriched material. This cycle takes time. A lot of time. But Webb is detecting galaxies in the early universe that already contain these heavier elements. Which creates a serious problem. Because it suggests those galaxies didn't just form early, they lived through multiple generations of stars, far earlier than expected. In simple terms, it's like finding a fully grown forest, in a place where only seeds should exist. Hourglass. Where did the time come from? This is where things start to get uncomfortable. Because if galaxies appear older than they should be, then something in our timeline is off. There are a few possibilities scientists are exploring. 1. The universe formed structures faster than expected. Maybe gravity worked more efficiently in the early universe. Maybe matter clumped together faster. Or perhaps something boosted early star formation in ways we don't yet understand. 2. Dark matter behaves differently. Dark matter, an invisible substance making up most of the universe's mass, is thought to act as a scaffold for galaxy formation. But what if its properties are slightly different? What if it clumps more quickly, interacts in unknown ways, or evolves over time that alone could accelerate cosmic structure formation? 3. Our models are incomplete. This is the most grounded explanation. Not that everything is wrong, but that our models are missing key ingredients. After all, cosmology is based on simulations, and simulations are only as good as their assumptions. 4. The radical possibility. And then there's the idea that sits at the edge of science, but refuses to go away. What if the universe didn't start from a true beginning? Repeat button before the beginning? 7. Some theories suggest the Big Bang wasn't the absolute beginning. Instead, it may have been a transition, a bounce, or the continuation of a previous universe. This idea appears in models like Big Bounce, cyclic universe theories, loop quantum cosmology. If that's true, then our universe may not have started as a blank slate. It may have inherited structure, memory, momentum. Milky Way. When categories start breaking. 6. For as long as astronomy has existed, it has relied on one powerful tool: classification. We organize the universe by putting things into categories: stars, galaxies, quasars, black holes, nebulae. Each category represents more than just a label. It represents an understanding. When we call something a galaxy, we're not just naming it, we're saying, we know how it forms. We know how it evolves. We know how it behaves. But now, the James Webb Space Telescope is showing us objects that don't follow those rules. Objects that are too compact to be normal galaxies, too bright to be explained by stars alone, too energetic to behave like anything we've seen before. Some resemble early versions of quasars, but not quite. Others look like galaxies, but with properties that don't make sense at their age. It's as if the universe is producing hybrid objects. Things that exist in between categories. And that creates a deeper problem than it first appears. Because when categories fail, it means the theories behind them are incomplete. Brain. The hidden meaning of categories. Categories are not just organizational tools. They are compressed theories. They are the result of decades, sometimes centuries, of observation, modeling, and testing. So when Webb reveals objects that blur those lines, it's not just showing us something new. It's telling us, our assumptions about what the universe is allowed to create may be too limited. This is where science becomes uncomfortable. Because it's one thing to discover a new type of object. It's something else entirely to realize the boundaries themselves may have been artificial. Globe. The cosmic web problem. 7. If strange objects were the only issue, cosmologists could adjust their models and move on. But Webb isn't just challenging individual objects. It's challenging the architecture of the universe itself. On the largest scales, the universe forms a vast structure known as the cosmic web. This web is made of filaments of galaxies, massive clusters, enormous voids between them, and according to our best models, this structure takes time to form. A lot of time. Gravity slowly pulls matter together. Dark matter provides the scaffolding. Over billions of years, small fluctuations grow into massive structures. But Webb is now hinting at something unsettling. Some large-scale structures appear to have formed too early. Not slightly ahead of schedule, but early enough to raise serious questions about the timeline itself. Stopwatch a universe in a hurry. This creates a pattern we can no longer ignore. Galaxies forming too early, chemistry evolving too fast, structures assembling too quickly. It's as if the universe wasn't slowly building itself, it was rushing. And that raises a critical question: why? Puzzle piece. Possible missing pieces. Scientists are now exploring multiple explanations, none of them simple. Small diamond. Unknown. Early physics. There may have been processes in the early universe we haven't yet discovered. For example, exotic particle interactions, temporary changes in physical constants, unknown energy fields. These could have accelerated structure formation dramatically. Small diamond. Rethinking dark matter. Dark matter remains one of the biggest mysteries in physics. If its behavior is even slightly different than we assume, everything changes. It might interact weakly with itself, form clumps earlier than expected, influence galaxy formation in hidden ways, and because dark matter makes up most of the universe's mass, even small changes could have massive consequences. Small diamond. Observational bias. There's also a more cautious possibility. We may be seeing only the brightest, most extreme objects in the early universe. In other words, maybe these galaxies aren't typical. Maybe they're rare, but highly visible. But even that explanation has limits. Because the number of these objects keeps increasing. Globe the shift toward exoplanet 6 while Webb is reshaping our understanding of the early universe.